So I just want to give our experience applying a DSL actually, and combining that with AI and ChatGPT and all that. So let me go back a few years where we started. We had a research paper, back then we were quite active with these papers, about synthesizing user interfaces and, using functional programming abstractions. The talk before me in the other room had a similar great talk, and around 2020 there were quite a few people doing this kind of research, like how can you use functional programming abstractions to model user interfaces, data flow, etc., etc. You probably have heard about Elm and languages that were invented to solve problems, especially in the web domain where we work. So this is something similar, but we had a different inclination to start with. So we had something like, okay, let's say we deal with web application development. Let's pick problems that we want to solve. For example, how does data travel through the different pages? What is the informational data flow as you progress in a website? And then we have to come up with abstractions for it. So we said, okay, well, the vocabulary in this DSL is going to talk about forms, fields and types for model types, etc., etc. And then you choose a syntax around them. To us, syntax doesn't really matter. A lot of people get bogged down in like, what language should we use? What language should we embed our DSL into and things like that. We're quite okay with external DSLs. They're easy to implement. So we weren't very concerned about the syntax. So we started out with something simple like, okay, let's define forms where we describe what kind of data is going to be contained on those forms. And then you could use relatively rich types like you could introduce composition using records. And that's pretty much it. You can have recursive types, etc. And then at the end you say, okay, here are my model types, and then I want to have a page that collects one of these types. That easy. And then, so this is, remember, 2019, 2020. So we had this system where we actually parsed relatively complex English sentences. We didn't have like LLMs back then. So we wanted to have this aim where you could, we had a project, a different project. I wasn't even going to bring it up, but we had a project called WebSharper+F, which was an online IDE that allowed you to do F# web development. It was all based in the cloud, hence the name. And you could basically just work on projects, web projects, without anything run on your local machine. Obviously, it didn't work quite like that because we had issues with like separating processes on the back end, etc. So we decided to have a local component that you install, but you still have a web front end, and then you do all that stuff. So in WebSharper+, we had this idea that what if we could talk to this web application? And back then there were these standards kind of starting up, like web speech for synthesizing web-based text into voice. Speech recognition to understand as a website what the user is trying to say. But these were very, very primitive at the time. So for example, the punctuations and having just sort of an understanding of what the text is structured was very difficult. So you could pipe this input from the web speech or web whatever recognition technology to some kind of external service to have it punctuated, and then you get it back as a structured text, and then you could parse it maybe and do something. So we had this project basically starting out as something like that, sort of almost like an extension to WebSharper+, but we decided to have this sort of as a separate component. We even built a little UI around it where you could have a syntax highlighting, etc., and you could write these specifications, and with the run button you could extract the code behind it and save it and maybe stick it in a project and then even change it. And that's exactly how we use it ourselves. So this was a way for us to bootstrap some applications where we needed to quickly gather data and then do something with that data, like very simple applications. And we call this UI synth. Here are some examples with the syntax. The reason I'm having these two slides is to show you that from the same specification, we could actually synthesize code that looked different. Not the code, but the end result. So the web front end didn't really need to be exact. This comes out from what we call templating. So the code we generate is, I call it abstract applications. So they are not instantiated with a concrete UI or a set of templates. Those come later. So you can take an abstract application, sort of skin it with some templates, and then you get the application. And it could look like this, or it could look like that. It's completely up to the user how you want to have this. Now, obviously, for most developers, especially like backend guys, they are not really skilled with like making UIs, especially with HTML and JavaScript and CSS. That should be probably best left to some designer. So the idea was that we externalize the presentation level artifacts from the code base. Like in our F# code, you never see HTML combinators, CSS or anything like that. So you externalize that to templates, and then those templates can be bound either compile time or runtime and be pulled on the top of your abstract applications. So this is how we go from a DSL and such declarations to have a skeleton of an application, and then you put a skin over it, and then you have one of these UIs or anything more fancy if you wish. But in my talk and in this effort, we didn't really care so much about how the applications look, but you could actually make wonderfully designed public-facing websites if you wanted. It all boiled down to the designer of your choice. So this is how it started around 2020. And the whole idea was, I mean, here in the abstract, you can read it. I'm not going to, but it says, our ultimate goal is to enable end users to describe entire web application UIs and carry on a conversation with our system, describing incremental changes to apply on an ongoing specification. Remember, this is 2019, 2020. That's 4, 5, 6 years ago. While this may seem like a far-fetched idea, even partially enabling it can yield significant benefits and can promote further research to realize the full potential involved. This sounded really nice. Okay, let's jump to now, or relatively recently. So I asked ChatGPT, okay, what do you think about DSLs? And then this is exactly word by word what it says. This was ChatGPT 5. It says domain-specific languages are going to get a lot more emphasis, not just as a niche FP curiosity, but as a mainstream bridge between human intent and AI-generated systems. So then I went into, some details just to figure out what the AI was thinking. And then this is roughly the possible DSL plus AI roadmap that it kind of drew for me. So right now what we have is we can use DSLs as an AI-friendly spec. Basically, this means that AI understands the DSLs better than, for example, English or natural language is ambiguous. DSLs are concise, structured, machine readable, etc., etc. Now, this argument is rather weak because LLMs have excellent capability to sort of figure out what you want even from very vague statements, but that has limitations. So this is now, and in the short term, we're talking weeks, months, whatever. DSLs can become a contract between humans and AI. Many companies, GitHub included, are working on specification-first development, where specs are the source of truth, and then the coding comes on top. Well, this is exactly the idea here. So we, instead of talking in English, we use the DSL to convey our ideas, and then the AI generates and maintains the implementation, if we want, in multiple languages and multiple runtimes. So the same specs could be brought over to different platforms. Remember, like 5, 6, 7, or maybe even 10 years ago, a lot of companies started using web technologies for their games, like Angry Birds. I don't know if you recall that game, but they had this big, huge effort to have their application for Android, and then they wanted to port it to iOS, and then at the time they even had, I think, a Windows Phone version. All of those were done by separate teams, costing a lot of money and effort. And then they figured out, oh, we could just do the whole thing using WebGL and write it on web technologies, and then have one code base and just package it for different platforms. So it's the same idea here. You don't need to actually spend lots of money and have different kinds of people working on multiple teams just to enable the development on multiple platforms or maybe switching languages. You can just have AI do all of that work for you. So that's short term. And I think a lot of people are already using this. And I would like to think that this is going to be the near future, or is the current present as we speak. And then maybe in a little bit more time, in the medium term, we have DSLs become as a universal interface. So AI agents can use their own DSLs in between them, etc., etc. So this is roughly what ChatGPT thought of the possibility of DSLs arising. And I like this slogan, the rise of the DSLs. I think we're going to see this a bit more. All right, so why is this more important than before? So first of all, DSLs have a very high potential to eliminate or at least reduce AI hallucinations, simply because they narrow the vocabulary, they narrow this interpretation space that is used as a ground for code synthesis. They also bridge between the developer and AI, and basically, like we said, I think the biggest advantage is that the DSL is a source of truth. The specification remains a source of truth. And then from there, we use different tools, AI itself, to synthesize the code for whatever platform, whatever set of tools or languages or whatever. So basically, ChatGPT thought that DSL design, so designing programming languages has always been very challenging, but very fruitful activity. So here, it thought that people who will be designing DSLs are going to be more widespread. Basically, it's going to be one of the top FP skills, it predicted. And I actually believe that. So we'll have a lot of need for people coming up, designing languages, external or embedded, whatever, and then provide some kind of means of using those DSLs for something interesting, including code synthesis. All right. Now let's talk about the technical details. So we have started out with something small, little mini scale DSL to describe model types and basically that's it. And using that data or shape or schema to actually generate code. But what kind of code did we generate? I think these details are not that interesting because it just happens to be one of these choices that we ourselves made. Obviously, we were heavily invested in F# web development, so we used WebSharper, and this is our choice. But I imagine that many people will have different choices. Maybe you want to generate, I don't know, some other language or whatever. So the technical details here, I'm just going to basically go through real fast and maybe even just save some time for questions for later. So WebSharper basically allows you to do full stack development. So you have client and server concerns. One of the main things that we have on the server side is sitelets. And then on the UI side, we have functional reactive client-side development. For a large part of this current work, we are using composable forms, which is a separate abstraction that we built. I wanted to quote the research paper, but I mean, the crowd here looks, and I'm glad that you guys are very inclined academically. So if you are interested, I can give you the references. So these WebSharper forms allow you to declaratively or declare user interfaces in a sort of an abstract way without any kind of reliance on what the actual forms are going to look like. And then you can parameterize, you can later on put a skin on that abstract definition as we talked about earlier. So a lot of that concerns this type-safe templating item here. So that's done using the WebSharper UI, which is the HTML combinator language, and the other facilities and capabilities around that, including templating. So we'll talk a little bit about that. And at the end, I want to discuss the DSLs and the source code generators that we have implemented for WebSharper that make all of this possible. So let me just jump through. So first of all, if you want to try WebSharper, you don't need to install anything. You can just go to a website. You can go to this. I don't think you can see it. It's not clearly visible, but try.websharper.com. Let me show you what it looks like. So it's basically like a bunch of people's snippets. And there are some pretty interesting ones, like, you know, Pythagorean tree and so on. I like to just demo with this pool game. So remember, this is all written in F#, and here you can see the source code. This is the largest snippets, as far as I know. It's about 1,400 lines. It's all type checked here on the fly. You get code completion and some basic ID capabilities here in the browser. And as you see, it's rendered already into JavaScript and run. So, I mean, we could view this in a full frame and then play with it if you want. That was a terrible shot. But you get the idea. And there are tons of little snippets that you can learn from. The idea here is that all of this is client only. It doesn't talk about anything about the server side. So this is not full stack. It's just client stuff only. All right. So let's talk about the server side in WebSharper. So for example, here's probably the smallest microservice that you can implement in WebSharper. We define our endpoint type, and I like to alias it using the endpoint type to be int, so integers. And then we have a sitelet that we infer from this endpoint type, basically by providing a function that maps values of this endpoint type to actual content that we can serve. So here we say that any incoming I, we want to serve back a text, a string, that is the square of that I. So silly microservice, but you get the idea. And you can take this a bit further. You can say, oh, well, my endpoint type now is a discriminated union. So we can start modeling multiple shaped entry points. So my homepage sits at / the web root, but I have a weather service that actually needs the city, and it will provide some info back to you. And then here you can have what we call endpoint modifiers. So these are attributes that you can place on the endpoint types and the various shapes to tell the compiler to generate or make a sitelet that has various requirements, like taking the input as, I don't know, like a JSON object posted to the endpoint instead of a get command. So you can encode all of that in the type itself, and then you provide functions that actually describe what the home page and the weather page will look like. And then at the end, you basically say, just give me my application given this endpoint type. And if I get a request for the home page, we serve the home page. If I get a request to a weather endpoint, provided the city is there, then we serve, in this case, JSON with the weather information. Now, obviously here we say, okay, what happens if I pass 2 cities, or we have an informed or malformed URL to address this endpoint? Well, you're going to get a 404. It's going to be a not found. So basically the sitelet runtime takes this type definition, and then it will act as best as it can to parse out from the request what you wanted or intended. And in every other case, you're going to get a not found. Okay, so we take something like this. This is basically the skeleton of almost every single full stack WebSharper application. And then you can start adding additional little, like sprinkle in some additional little code. So here, there's this client helper that comes from a type, the UI.clientServer type. This client helper allows you to take a function that had been attributed to be on the JavaScript side. So this is going to be running on the client, but we write it in F#. And then in the server side sitelet, we are able to embed this dynamic content into the server rendered HTML using the client helper. So what happens here is that we actually serve like a dummy placeholder along with some JavaScript that has been generated, but the JavaScript is run immediately when the page is served, and it just basically lights up that placeholder. And in this case, it will say whatever the main function has been defined to do. Now, this is typically where you embed the dynamic functionality and not just presentation layer. So you could have like a skeleton page, and then once it lights up, it loads from the database all the orders or items or whatever, and then suddenly the whole page populates. But you can also do server-side rendering with that predefined data if you want. So all of that complexity is very easy to handle with WebSharper. Okay. And just one last bit, the hydration. This is exactly what I was talking about. On your client-side function, you can make a distinction whether the content that you're producing is produced on the server or the client just by using that isClient predicate. And then you use the hydrate helper instead of the client one. So these helpers make it, I think, pretty trivial actually to write applications that embed dynamic content, and you write both of those content, server side and the client side, in F#. So basically our entire code base is in F#. We don't write a single line of JavaScript. You may ask what happens with dependencies, NPM packages and all that. Those are automatically managed, and I'm happy to discuss that or answer any questions on that. But this is the framework, this is what the code looks like, and this is the code that we're generating from our DSL. All right, so now let's talk about the templating. This is what it looks like. So we have a type provider. I mean, some of you guys are F# developers, so you may have heard about template or type providers. So these are some metaprogramming capability, but instead of generating source, they actually generate assemblies dynamically during compilation. So here we have a templating type provider, which is the one coming from WebSharper templating. It takes an HTML file, it traverses the file, finds placeholders and various WebSharper specific attributes, and then it generates you a type space. And the type space in this case can be instantiated, as you can see, my template.main, that's probably an inner defined template. You instantiate it, you fill all the placeholders, and then at the end you say .doc, which basically has everything filled out and makes an HTML that you're ready to serve. And then you stick this into your sitelet, like right there, for example, and then it's served back. So your response will be then based on a template. This is very important because now you can take your template, and if you want, you can change it even runtime. I mean, obviously it's better if you change it at compile time, because then you get guarantees from the compiler that the template that you are substituting in has the same placeholders and event handlers and everything defined. If you are opting for runtime switch, then you might actually get a runtime error. So it's probably best to do it at compile time. But if you have designers who are skilled enough, they can provide you templates basically allowing you to switch the entire look and feel of your web app without redeploying the app. Okay, and the last bit, this is actually the researchy bit. This talks about, we actually call this at the time of publication, we called it piglets. That was, I think, an acronym for pluggable UI-lets or something like that. Those are reactive forms in our new terminology. So WebSharper Forms is a library that provides you with reactive forms. So they come with at least two layers. One is you define an abstract form using those form.yields and the star combinator. So you basically compose up forms, and then with the form return, you actually can provide a function that takes these individual inner composed values and then returns whatever you're composing out of them. So in this case, we take all of those V and VI values and we make a tuple out of them. So combining everything into a tuple and then return it. And then we have a second component. So I don't know if you're familiar with the pipe operator, the forward pipe, but in F# it's like putting the argument first and piping it into function, a very widespread idea. So here we take that and we pipe it into form.run. So it takes that combined tuple and then it does whatever with it. This is after the submission. So this is when all the validators and everything said it's ready to submit, and then somebody actually clicked the submit button. Now the question is, if all of this is abstract, how do we actually define the concrete user interface? Well, that happens here in the render function. So here we can say, oh, we get all of those different value producers, and now those v sub i's, they're actually reactive variables of the type that you define them to be. And then as reactive variables, they can be bound inside templating. So for example, if you have a placeholder that expects a value, if you bind a reactive variable on that placeholder, it will be a two-way binding in the resulting app or page. And then here we have some facilities around submitters and being able to submit. So here the submit is probably an event in the template, and then it just triggers the submitter with the values. But you can define validators, etc., that could block the submission until some condition is fulfilled. So, but this is the general skeleton idea. And what the interesting part here is that if you cut down this bottom half, so the render function, you can define your abstract forms. You can even define what to do with the data that comes from these forms. So you could write your application abstractly without any UI, and then you can start piping it into render functions and then make an actual browsable application from it. Okay, I'm running out of time, so I'm gonna just get going here. So the DSLs and implementing DSLs, naturally you have different ways to do it. One of the ways that I actually use myself is just using Lex and Yak. We have these libraries available for WebSharper, and then simply I use this to implement the external DSLs. You could use whatever you want. And then the last piece is the source code generators. This is a rather interesting idea from a few years ago. C# has source code generators, F# does not. It has type providers instead. But there are many people discussing it, and some people have prototypes and whatnot. So we implemented source code generators for WebSharper, which is a custom F# compiler. And we also have IDE support in Visual Studio at the moment. So you basically can have warp files. This is the new name that we branded. So UI synth was switched to what we call warp. And then you have ID support to enable you to see the generated code behind all of those warp files. So the key learnings, I think this is the moment of truth here, is that LLMs and what we see as AI currently are progressing at an extraordinary speed, but there are many problems, especially in our domain where we synthesize code. So there's always a constant source of hallucinations. You probably have run into this several times, that you have a conversation with your LLM, and then 5 or 10 iterations later you get back into the same shoes, and then suddenly you realize, oh man, this is just wasting my time. And then all of this query engineering, that you have to be smart in how you ask something, I mean, that's just silly, right? I mean, that's a temporary hack that these companies are using because of the restrictions and limitations of the whole idea that this is all just nothing but a statistical search. I think, well, I will have my conclusions later, but right now, these have been perfected to a degree that it seems like the solution, but I actually think we'll need maybe a different way to actually get code synthesis in the right way. And with all of that, if you think about like what cost is involved, all these servers running, you know, in some remote location and answering your queries and doing tremendous amount of work just to produce a 2-line synthesized code, that seems like a waste of energy, waste of money. Obviously, it's been hyped up and it has great capabilities, so the hype is justified, but I think the cost here is extreme. So basically, I still tend to think that obviously the human language specification is ambiguous, but LLMs are great at reducing that risk. So everything seems okay, but there's a huge cost, and especially the reliance that you have on these platforms. Imagine that your application or your AI-based development uses ChatGPT or Anthropic or whatever. You know, if those companies, if their service stops, then your developers are going to be stalled. So we need something that can be run locally. So in the future, I would aim for something where I can have guarantees about the synthesized code. So this is very important. This to me suggests maybe a different technological angle for AI is needed, where we can have AI reason correctly and then preferably run locally. And then in the meantime, you have DSLs to help sort of bridge the gap, the communication gap that may exist between the AI and ourselves. And then just a few slides about where we're heading. I know we have only a few minutes, so I'm just gonna rush through these. So we believe in the specification as the source of truth idea. So the prototype that we have taken from a few years ago, it's been extended into a full-fledged DSL that looks pretty much like this. I highlighted some of the parts that are interesting, where you can specify like constraints, validators, optionality, default values, some interesting types in your model. And then we have what I call a templating sublanguage that allows you to work with these external design artifacts and still view them as strongly typed. So you declare what's inside of your templates, and then we have code checking and semantic analysis based on that declaration. So for example, we can define inner templates and their placeholders and their types. And then when we bind an actual model type to the template, we can use these and we can type check that declaration. The same thing here, like, okay, we can bind model types to the template, but how can I actually collect something using those templates in my UI? So that's collection with binding, but at the end with the capability to submit the data that you're collecting with potential validators. So then this is what the language looks like. So here, just a couple things. We have the ability to take one-to-one mappings. We have the ability to take a large structured data and map it to a placeholder. And then we have iteration capabilities, and all of this is type checked. And remember, because this needs my file to be declared, if I change anything in my template, I get immediate red squigglies in my editor. So this basically is strong typeness over the designer and the artifact that they are producing for us. And then me as a developer, I'm free from everything design related. And then at the end, we have the endpoints. These are the different pages of my application, or the different entry points to my microservices. The language has been enriched a lot, so you can have a local model, you can have ways to describe what kind of placeholders are getting what kind of values and how these values go and propagate to other entry points of your application. All right, and this is what it roughly looks like. So we talked about the WebSharper Warp plugin. This is in Visual Studio. So we believe in that the specification will happen using Warp or your own DSLs, and you have the capability to define these DSLs. And then you customize the generated code in F# or in JavaScript or TypeScript in our case. And these specifications and customizations, they go hand in hand, they live together. But the source is the spec, and your updates together make up the application. And then just as one last slide, we have an interactive environment with the Visual Studio plugin. So you can talk interactively in this environment, and you can type in like, oh, here's my sitelet, and then you can test it immediately inside Visual Studio. Or you can, have like 1 + 1 = 2. Okay, well, give me a button that if I click, it will say hello world, and then you can have it. It's all of this is interactive, dynamically compiled on the fly to JavaScript and run inside Visual Studio. And for example, all the charts, and we talked about NPM packages and so on, and dependencies, they are brought in automatically. So here we have a chart.js component, 4 or 5 lines of F# code, and now I'm charting numbers in Visual Studio in an interactive environment, in a REPL. And I think that makes developers extremely productive. And so with that, I would like to conclude, and thank you very much for being here. And if you have any questions, please ask.